Okay, for question number 7A, it says that a double slit source is separated from a screen by 1.4 meter. The distance between the two slits is 0.04 millimeter. Second order bright fringe is m equals to 2, measured to be 4.6. Okay, first of all, you have to determine this one, yang double slit ke, single slit ke, thin film ke, apa. So here dia memang cakap lah, double slit source. So immediately you know that this one is yang double slit. Okay, and they says that the distance, which is the D, ini question number 7. Dia kata distance capital D is 1.4 meter. Distance between the two slits, small d, 0.04 times 10 negative 3. Make sure everything is in the same unit. Easier if you use SI unit. And dia kata second order bright fringe. So immediately dia kata M dia equals to 2. Memang disebut lah. So that one is kamu tak perlu fikir apa. Measured to be 4.6 cm from the center fringe. That means Y equals to Y bila second order is equals to 4.6 times 10 negative 2 meter. Determine the wavelength of the light. Okay, yang ini adakah dia constructive or destructive interference? Kalau kamu baca soalan dia. Constructive sebab apa? Sebab memang dalam soalan tu dia kata second order bright fringe. So immediately you know that this one is constructive. So sometimes in exam, maybe they tak direct sangat lah. So for constructive interference, the equation will be Y equals to M lambda D over D. So we can use this formula straight away. Bila Y2, bila M equals to 2, value is 4.6 times 10 to the power of negative 2. M kedua, lambda dia adalah yang kita nak cari, D dia 1.4, D kecil dia adalah 0.04 times 10 negative 3. Okay, to do that you should get lambda equals to 6.57 times 10 negative 7 meter. Okay, jadi kita tanda ya. Okay, kalau markah dia kita tanda terus lah. In terms of marks dia, for 7A, if you substitute everything correctly, you get 1 mark. Tadi lah semua nilai tu. And then if you find the answer, you write down with the correct unit, you get 1 more marks. Okay. That one is for question 7A. 1. 7A2, dia kata distance between adjacent bright fringes. So adjacent bright fringes tu actually indicator untuk kamu kira delta Y. Adjacent yang seterusnya. So dia tak ada M, dia just lambda D over D. Kamu masukkan semua nilai dia, lambda tu baru dapat tadi. D tu pun kamu masukkan je, 1.4. And D kecil tu 4 times 0.04 darab 10 negatif 3 tadi tu. If you do the delta Y, sepatutnya kamu dapat 2 times 3 times 10 negative 2. Okay, in terms of marking, again substitution, everything correct, you get 1 mark. Okay, final answer with unit, you get 1 more mark. Okay, ada soalan so far? 7A.
No, sir.
Okay, for 7B, kata camera lens is coated with thin film of magnesium fluoride to eliminate certain reflected light. The refractive index of the magnesium fluoride and the lens are 1.38 and 1.5. The minimum thickness of the thin film is 75 nanometer. Determine the wavelength of eliminated reflected light. So ini adalah thin film. Memang dia sebut banyak kali ada thin film, thin film. So the first thing that you have to do, kamu lukis 2 line. Macam biasalah. Draw the 2 line. Okay, and then kamu identify dia punya end dia tu, N1, N2 and N3. So in this case dia adalah coating untuk lens. So lens ni bawah sekali. Okay, so lens dia should be 1.5 and the coating dia tu on top of the lens should be 1.38. Dan atas lagi adalah air 1. So from this sequence ni, N1, N2, N3 ni, adakah dia in phase ke anti phase? Nombor dah menaik kan? So, in phase ke anti phase?
In phase.
In phase sebab nombor dia berturut, menaik atau menurun, itu adalah in phase. Okay, so in phase ada dua benda yang akan berlaku lah, satu konstruktif, satu lagi destruktif. Okay, based on the question, dia kata if the minimum thickness, so dia kata T min kat sini is equals to 75 nanometer, determine the wavelength of the eliminated reflected light. So eliminated reflected light maksudnya adakah dia konstruktif ke destruktif?
Constructive.
Dia sebenarnya adalah destruktif so dia kata eliminated tu dia hilang lah, dia tak ada. Dia keyword dia eliminated ataupun non-reflective light. Kalau dia kata reflected light, okay, yang tu ada cahaya terpantul lah. Kalau non ataupun eliminated, dia tak ada. Okay, so ini sepatutnya adalah destruktif sebab dia adalah eliminated. Okay, so for destructive in phase, the formula should be 2ND, macam biasa lah, M plus half lambda. Okay, so once you identify the punya formula, now you can identify the punya values yang dalam tu lah. Macam yang T ni diberi, N ni tengok T tu kat mana, T tu kat tengah kan, so kita pakai N yang tu lah. Yang M ni kamu kena tentukan, M dia berapa sekarang ni?
Kosong.
M dia sama dengan 0. Sebab apa dia kata T tu minimum. So bila T ni minimum, basically you want to have the smallest value on the right hand side ni. Kalau equation kamu tak ada half, that means you have to substitute M equals to 1. Like this case, M kamu ada half kan, so M ni sama dengan 0. Lagi kecil kamu boleh masuk nombor dia, masukkan nombor paling kecil. So in that regards, M is equals to 0. So 2N dia adalah 1.38. 0 plus half lambda. T min tu diberi ya, sorry. Okay, now you just have to solve for lambda. This one you should get lambda equals to 4.14 times 10 negative 7. Okay, so for this one maka ada 3 meter. So if you use the concept that M equals to 0, you get 1 mark. Okay, so obviously if you want to choose M equals to 0 tu, you have to get the equation correct lah. Kalau tak dapat ni. And then gantian, if you substitute everything correctly, you get 1 more marks. And then lastly, if you get the final answer with the correct unit, you get 1 more marks. So total is 3 marks. Okay, that one's for question 7B. For 7C, dia kata light of wavelength 500 nanometer is directed perpendicular to the diffraction grating. The first order spectrum is at 22 degree from the zero order spectrum. Calculate the numbers of slit per meter on the grating. Okay, so macam biasalah, once you get this untuk chapter ni kan, once you get the question, kamu identify dia tu single slit ke, double slit ke, diffraction ke, diffraction grating ke, ataupun tintulan. In this case, dia memang ada sebut dalam soalan tu, dia adalah nak cari grating kan. Dia ada sebut perpendicular to diffraction grating. So that means this one adalah diffraction grating. For diffraction grating, actually we only have one formula. D sin theta is equals to M lambda. Okay, now we can take out the information from the question itself. Dia kata wavelength adalah 500 nanometers. The first order spectrum is at, so that one is your theta is equal to 22 degrees from the zero order spectrum. Okay, so that means dia punya M tu paling minimum. In this case, M dia paling minimum berapa? 1. Kalau kamu letak 0 dan everything jadi 0, then there's no points lah if you want to calculate anything. So You can find the D straight away if you substitute all the values here. Lambda is given, theta is given, M you already know. So now your D is equals to M lambda 500 divided by sin theta. So make sure your calculator, sebab angle tu dalam degree, everything is in degree lah. So if you do that, you should get D ni sama dengan 1.33 times 10 negative 6 meter. Okay, ini adalah separation between slit. Okay, so ini adalah separation between slits. So kamu bayangkan dalam gratings so ada thousands of slits. So jarak antara dua slit tu, ini jarak dia sangat close lah, negative 6 . But the question actually want to find numbers of slit per meter on the grating. So maksudnya 1 meter ada berapa banyak slit tu. So that one will be N. So N sama dengan 1 over D. So if the question want you to find in meter, so make sure over here is in meter lah. Kalau dia nak cari dalam sentimeter, dekat sini kau tukar sentimeter siap-siap before kau masukkan dalam N tu. So 1 over 1.3 times 10 negative 6, you should get 7.52 times 10 to the power 5 slits per meter. Okay, or slits M minus 1. In terms of marks given, if you do the first step tu, kamu dapat D correct tu, maksudnya kamu gunakan konsep yang betul, get 1 marks. Okay, and then if you gantian everything correctly, 1 over N tu, you get 1 more mark. Final answer correct, you need another 1 mark. For question number 8, dia kata ultraviolet light of wavelength 280 nanometer is used in an experiment of photoelectric effect on the lithium. Lithium surface has a work function of 2.5 electron volts. Okay, so this kind of question, if you want to solve it, number 8, ni macam biasa saya selalu suruh kamu lukiskan. Okay, so you draw the metal surface tu, indicates dia ada elektron dalam tu, and then kamu indicates ada incident photon, and then kamu indicates ada ejected electrons kalau ada lah. Okay, now in this case kata light of the wavelength 500 nanometer directed perpendicular. Okay, itu yang datang. Okay, sorry, salah baca soalan. Ultraviolet light of 280 nanometer is used in an experiment. So maksud itu yang datang lah. Lambda dia sama dengan 280 nanometer. And then the lithium surface has a work function of 2.5 eV. So work function tu kamu label kat metal tu lah, 2.5 electron volts. Determine the maximum kinetic energy of the photoelectrons and the stopping potential. Okay, so if you have incident light punya wavelength, straight away kamu boleh cari dia punya E. Okay, now you can apply Einstein equation where E sama dengan yang datang kan, sama dengan yang guna untuk atasi tambah yang baki. Okay, but in this case they want to find K max tu. So incident light tu, since they give you in terms of lambda, you can straight away calculate E tu, boleh kira separately or you can calculate inside there, tak masalah. So use HC over lambda. So masukkan dalam tu, W0 tu is in EV. So because energy tu we have a constant H, that means the values of E tu will be in joule. So might as well change everything in joule lah. So work function tu you have to multiply with E. Elementary charge punya values. Okay, and then you should get the value for K max. HC over lambda ni saya substitute terus lah. H dia adalah 6.63, kamu boleh check dekat dia punya constant. Speed of light is 3 times 10 to the power 8, and then lambda dia adalah 280 times 10 negative 9. Solve this one, you should get K max equals to 3.10. Okay, SI unit will be in joule. That one is easy, tak ada masalah. Okay, jadi kita tengoklah solution dia macam mana. That was for A, yang B tu dia kata stopping potential B. So daripada Kmax tu kamu boleh tengok lah, sebab Kmax ni sama dengan EVS. The whole thing over here is equals to EVS. Kan kamu boleh tulis antara dua tu lah. So Kmax is equals to EVS. That means 3.1 times 10 negative 19 tadi tu. Momentary charge 1.6 times 10 negative 19. And then VS ni adalah stopping potential. So final answer dia tu unit dia adalah volt. Okay, let's try to look the marker. Okay, if you apply the equation here, you get straight away get the mark. So here kalau kamu tengok the marker tu ada dekat dalam equation tu lah. And then gantian, if everything correct, you get 1 more marks. Final answer with unit joule, you get 1 more marks. So yang A 3 marker, yang B tu gantian, you get 1 marks. Final answer with unit, you get another 1 marks. So total here would be 5. Okay, that one's for question number 8. For question number 9, it says that calculate the de Broglie wavelength of an electron accelerated by a potential difference of 1.0 kilovolt. Okay, so for question number 9, disuruh cari lambda given that the potential difference is 1 kilovolt. So itu sebenarnya dia punya V. Okay. So to solve this one, basically kalau ini basically formula yang kalau chapternya ada 2 formula je, sebenarnya tak ada. Ada satu formula untuk momentum tu. So formula yang 84 dan 85. 84 tu lambda sama dengan H over P. 85 is equal to lambda sama dengan H over square root of 2m EV. Okay, EV tu kalau ditanya kinetic energy, then you can change K lah. EV tu jadi K. Tapi sekarang dia jadi potential. So boleh dia terus masukkan V ni. Substitute V inside here. And then E tu 1.6 times 10 negative 19. Yang ini adalah electron. So mass tu mestilah mass of electron. Okay. So this one will be mass of electron, which is 1.6 times 10 negative, salah. To E. Mass of electron is 9.31 times 10, 9.11. Ingat 9.11 times 10 negative 31 kilogram. Okay. And then yang lain tu samalah 6.63 times 10 negative 34 untuk Planck constant. Okay, markah dia. Dua saja. Gantian everything correct, you get 1 mark. Okay. Final answer with correct unit, you get another 1 mark. In the case of deuterium, atom called neutron, the mass of 2.01, okay, dikasih mass dia, consists of proton and a neutron. Okay, even if you don't know neutron tu apa, you still soalan dia still beritahu dia ada a proton and a neutron. So maksudnya satu proton, satu neutron. Okay, and also determine the binding energy of the neutron in mega electron volt. Okay, so neutron ni sebenarnya adalah H21. Okay, so number of proton dia akan jadi 1, number of neutron dia 1, 2, 1 lah. Dalam soalan memang kasih proton is a, neutron pun A, so 1, 1. So to solve this one, you can apply mass effect formula first. Okay, sebab kamu nak cari E kan, binding energy. So binding energy is equals to delta MC square. So delta M tu kira asing lah, massization. So Z MP plus plus NMN minus dengan mass of nucleus. Okay. Mass of nucleus ni diberi, which is 3.01 for 102. Okay. Dan ini yang apa tu, MP dengan MN tu tengok dia punya list of constant tu, masukkan nilai dia. So yang ini 1, ini 1. So then you should get delta M equals to 0.0018 for U. Daripada situ, you can apply E equals to delta MC square Sebab kamu nak dapat dalam mega electron volt, kamu boleh pakai U ni terus darab dengan 931.5. Ini sebenarnya unit the U, yang ini adalah mega electron volt per U. Unit tak perlu tulis, ada warna lain. So yang this one you don't have to write, I just want to show. So notice that dia tak ada square apa, dia memang macam tu je, darab 931.5. So this one you should get 1.71 mega electron volt. Okay, so tengok skema dia. Okay, if you substitute Z dengan N tu dengan jawapan dia 1, you get 1 marks. Okay, gantian everything correct, the rest of the numbers are correct, so you get 1 more mark. Final answer with the correct unit, you get 1 more marks. And then for the second part tu, gantian correct 1 mark, final answer with unit 1 mark. So dekat sini je 5 markah. Simple punya question, 5 markah. Okay, then the next one, yang last tu dia kata the activity of a sample containing radioactive. Okay, tengok macam mana nak selesaikan. Yang B tu dia kata activity A is equal to 6.4 times 10 to the power of 4 becquerel. Lepas tu dia kata when T is equal to 12 minutes, the activity is A equals to 2 times 10 to the power of 3 becquerel. Calculate the decay constant, lambda, and the half-life of, so dia nak cari lambda and T half of the AG108. Okay. Okay, sebab dia kasih ada 2 becquerel tu, ada 2 aktiviti. Satu tu yang asalnya, lepas tu lepas delta T tu, lepas 12 minit, dia punya A tu dia 2.3. Okay. So jadi yang asal ni sebenarnya adalah A0. Kalau kamu tak nampak ni, kamu boleh buat timeline kot lah. This one. So basically, time tu flow daripada kiri ke kanan lah macam tu. Yeah, asalnya ini adalah A0. So after certain 12 minutes, A dia sama dengan itu. Berkurang lah. Obviously decay kan. Okay, the first question they ask you to calculate the decay constant. So you can apply, sebab kamu ada A dan A0, most likely kamu kena apply formula yang exponential tu. Okay. So if you leave everything in minutes, like the time there, you substitute minutes kan, lambda tu kamu akan dapat dalam per minute. So boleh biarkan je. Kalau per year, dia jadi year lah. Kalau per month, jadi months. So A equals to 2 times 10 to the power of 3. A0 is 6.4 times 10 to the power of 4. Exponential negative lambda ni kita nak cari T tu sama dengan 12. Okay. So make sure you press the calculator, cuba tekan, make sure kamu dapat lambda sama dengan 0.29 per minute. Okay, sebab per minute, sebab yang tadi kamu pakai minit juga. Okay, minit determine pun juga. Okay, that is for lambda. Okay, T half relation dia adalah ln 2 over lambda. So this one is easy lah. Apa lambda sama dengan ln 2 over T half kan. So kamu just rearrange, you should get the answer straight away. Okay. And for this one, dia tak suruh cakap dalam unit per. Again, you can leave it as it is. Dalam minit boleh, convert dan second pun boleh, tak ada masalah. Kalau saya biar je. Okay, markah dia. You substitute everything correctly dekat atas ni, you get 1 marks. Jawapan dekat lambda, you get 1 marks. Final answer with unit, you get 1 mark. Tak kisahlah sama ada minit ataupun saat tu, dia 2. Kalau betul, you get 1 mark. So here total marks is equal to 8.